A particle P of mass 0.2 kg is released from rest at a point 7.2 meters above the surface of a liquid container. Okay, so there's some liquid and there's a particle P which is released from rest. So U is equals to 0. And as it is falling downwards, the gravitational acceleration is going to be 10 meters per second square. And it is 7.2 meters above the surface of the liquid. So this distance till here, S is equals to 7.2 meters. P falls through the air into the liquid. There's no air resistance and there's no instantaneous change of speed as P enters the liquid. So whatever is the speed here, V is equals to, we're going to calculate that here. That is the speed that we'll use as the initial speed inside the water, because it's saying that no instantaneous change of speed is observed as the particles falls into the water. Okay. So let's find the speed first. We can do V square equals U square plus 2AS. So we can do square root 0 square plus 2 times 10 times 7.2, which comes out to be 12 meters per second. So this is going to be the final speed right before it hits the surface of the water, or the initial speed inside the water. Okay, so uh, there is no air resistance and there's no instantaneous change of speed as P enters the liquid. When P is at a distance of 0.8 meters below the surface of the liquid, so when this distance is 0.8 meters, P speed is 6 meters per second. So here we can say that V is 6 meters per second. The only force on P due to liquid is a constant resistance force of magnitude R Newton. Find the deceleration of P while falling through the liquid and hence find R. Okay, so we need to find the value of acceleration or deceleration in this region. So we know U is 12, S is 0.8, V is 6, and we're going to find the value of A, find the deceleration. So we can use V square equals U square plus 2AS. 6 square is equals to 12 square plus 2AS, which gives us A equals negative 67.5 meters per second square. Since they won't ask for deceleration, we're going to ignore the sign and write the magnitude of acceleration only. 67.5 meters per second square. Okay. Find the deceleration of P while it is falling through the liquid and hence find R. Okay, R is the backward force acting on this particle as it's going downwards. So this is going to be R. And the downward force is going to be mass times G, mg. So what is the mass of this object again? 0.2 into 10 is 2 Newton. So there's a 2 Newton downward weight. There's an R Newton backward force. And we already know acceleration, it came out to be negative 67.5. Let's use the formula. Forward force minus backward force is equals to ma. So 2 minus R is equals to m times A was negative 67.5, which gives us 15.5. Solve this, get R is equals to 15.5 newtons. Okay. The depth of the liquid in the container is 3.6 meters. So this total depth is 3.6 meters. The depth of the liquid in the container is 3.6 meters. P is taken from the container and attached to one end of a light inextensible string. Okay. P is placed at the bottom of the container and pulled vertically upward with a constant acceleration. The resistance to the motion is R Newton. The resistance to the motion of R Newton continues to act. The particle reaches the surface 4 seconds after leaving the bottom of the container. Find the tension in the string. Okay, so now the string is being pulled upwards. Oops. There's a string at the bottom of the container and it is being pulled up. So as it's being pulled up, there's going to be an upward force tension. There's going to be a downward force of weight, and there's going to be another downward force R, which is the resistance. Since the motion is upwards, so resistance is going to be downwards. So we're going to use forward force minus backward force, which are two forces, mg plus R is equals to ma. Okay, so we have to find tension. What is the mass of this particle? 0.2 kg, so 0.2 into 10 would be 2 plus, we have to find R is equals to ma. In fact, we're going to use the same R that we found earlier, which was 15.5. So we had found the R earlier, 15.5 is equals to 0.2 times A. Now we need A to find tension. Let's go back to this system inside the water. So the initial speed of the particle here is 0 and the total distance inside the water is 3.6. And what else do we know? We know the time taken here is 4 seconds. Let's use these to find A. So we can use S equals to UT plus half AT square. So 3.6 is equals to UT plus half AT square. Solve this, get the value of T. 3.6 into 2 divided by 16, getting 0.45 as A. Meters per second square. Okay, now acceleration is known. Let's substitute it here and get tension. Okay, let's calculate this. 0.2 into 0.45 plus 2 plus 15.5, which gives 17.59 as the tension in the string.